So this is project 3 for embedded systems class in the spring of 2020. This project is to measure fan speed using an IR detector and emitter. The requirements for this project are that the Arduino will use this IR detector and emitter to measure the fan speed, and we're going to measure that in rotations per minute. The way this is going to work is we're going to set up the emitter and the detector a few inches from each other, and when the fan breaks the beam between them, we're going to increment this RPM counter, and then we're going to use that calculation to figure out how many rotations per minute our fan is doing. The fan's going to be powered by a power supply module that's going to be separate from the Arduino. And we're going to set up our Arduino and our breadboard with the emitter and detector following the example of CM Palmer, which was given for this class, and all those resources are here. It was super useful and incredibly helpful for all of this setup information. We're going to put an LED as a sensor that will tell us when the beam between the emitter and the detector is broken, and this is just so that we are able to know that our system is working as intended, because the infrared light is not visible to the human eye. And this LED is going to toggle on and off every time the beam is broken, so then we'll be able to keep track of our RPMs based on how often this blinks. This implementation is going to use a round robin with interrupts design, and it's going to use the attach and detach interrupts functions. And then the final thing is that we're going to capture the RPMs over time, send them over the serial connection, and we're going to graph them in real time, just as we did with the last project with the temperature sensor. The hardware that you need for this project is obviously an Arduino. I'm using a Mega 2650. You need the IR emitter and detector, and you're going to need a 10K ohm resistor to go with those two. I ended up using 7 jumper cables. This will vary depending on your setup. I need an LED and a 1K ohm resistor to go with that. Then I need the power supply module, and then this 9-volt adapter is what we use to plug the power supply module in. For my motor, I got the Mega 2650 starter kit, and this came with a fan blade and a motor that you could attach. Because the blades of the fan are opaque, I needed black tape to cover them up. And then finally, the breadboard, the laptop, and the USB cable. So this is what my design looks like. In a minute, I'll walk through exactly how everything's connected, but you can see here is my IR sensor. I've got my little sensor light. This is my IR emitter, my sensor light, and then my IR detector is over here. And I've got my fan connected to my power supply module, and then everything else is wired into the breadboard. The way this works, and this is taken from CM Palmer's design, is pin 13 is going to connect to my IR emitter. I'm going to have my sensor on pin 12. And then my IR detector is going to connect to digital pin 2, because this corresponds to interrupt 0. And I'm going to have my 10K ohm resistor, and then this will connect to 5-volt power. This is actually the 5-volt and the ground is opposite in CM Palmer's design, but another student recommended to do it this way, and that works consistently for me. This was T. Joe's implementation, so I just went with that, and it works great. So I'm appreciative that we're all sharing our results with each other. Something that I ran into that was an issue was when I had the lamp on my desk turned on, so any artificial light in the room seems to overload the IR detector, and it doesn't work as planned. So for testing, and if you're going to implement this yourself, just keep in mind that you want to be in a room with just ambient light. In addition to this, I explained how we're going to connect the power supply module and the fan to that. And we need to cover up the blades of the fan, and that's important. And then we're going to connect the Arduino to the laptop, and the code for this is all going to be written in C with the Arduino sketch, and then the serial data and plotting is going to be in Python using Jupyter notebooks, and this is exactly like I did for the last project. So we'll walk through the code really quickly. This is taken directly from CM Palmer's site. I just had to make one modification, and I'll walk through this with you guys and point that out when we get there. So I'm saying that my IR pin is going to be pin 13 and my status pin will be 12. I initialized an RPM count, and then this RPM fun is my interrupt service routine function. And so in the example that we saw online, this interrupt function runs 2 times, and this 2 times for every rotation. And this is because the fan that he was using had 2 blades, but my fan has 3 blades, so I'm going to need to take that into consideration later. There are going to be 3 interrupts for a single rotation. Basically all that happens with the interrupt is we're going to increment the RPM count, and then we're going to toggle our status light. So what this means is that every time an interrupt happens, we're just going to say, okay, one of the fan blades passed through me, and then we're going to, that'll happen 3 times per rotation, and we'll count how many times that happens in a second, and we'll be able to derive our RPM calculation from there. For the setup, we're going to open up the serial port, and we just will attach this interrupt on the falling edge. And this means that the digital pin 2, which is interrupt 0, we want to have the interrupt happen when this pin goes from high to low. And that means that the connection is going to be broken between the detector and the emitter. When that connection is broken, that pin will change from high to low, and then we'll trigger an interrupt, we'll increment our RPM count, and we'll move forward. This is just to set up, we want our IR LED to constantly be transmitted. We don't ever want to stop that. And we're going to initialize a few values to 0. And then it's really simple in the loop. We're going to delay for 1,000 milliseconds. So that's just every 1 second. We want an RPM count. While we're doing the calculations of our RPMs, we want to detach interrupts. We don't want that to be interrupted. We don't want to change RPM count while we're doing this. So we're just going to protect our shared data and detach the interrupt during this step. For the RPMs, and this is the only change I made from CM Palmer's code right here, because I have 3 blades on my fan, I want this value to be 20 rather than as he had 30, and if you only had 1 blade, it would be 60. Then all we do from here is we write out our value to the serial port, and then we reattach that interrupt, and this will continue in a loop. And as you'll see later, our RPM values are going to be output in a Jupyter notebook, and I'll walk through that next. So here's the Jupyter notebook. This is actually the same thing as what I did for project 2. We're going to open up our connection to the serial port. We're going to set an animated plot, and I have some insider knowledge. I know how fast my fan goes, so 7,000 is high enough to be able to see the entire range. I'm only going to look at this for 100 seconds. That should be plenty of time. And we're just going to plot the RPM data as we get it every second. And that'll continue in a loop until we get all our points. And then later on, we will output our data to a CSV, and that's just so a user can export the data and use it in other functions. So now I'll move on to showing you the Arduino and my setup, and then we'll run the demo. So here we have our setup. It's a bit complicated, so I'll walk through each piece of it with you. And just note that that light is going to turn off when I break the beam and when I restart the beam. So that light is serving as a sensor. The connection for the light, we've just got this white wire, which is connecting us to ground. There's our light, our resistor, and then that red wire is connecting us to pin 12, which we had set for the light. So that is the same setup as we've seen for other lights. When we're looking at this motor here, this power supply came with my Arduino Mega 2650 kit, and as did the fan. As you can see, I've covered up the blades of the fan with black tape. It's very simple. I just connect the positive end of the fan to the positive end of the power supply, and so on with the negative end, and then that adapter is just plugged into the wall. This clear light here, that's my IR sensor. You can see this orange wire connecting it to pin 13, and our green wire is connecting it to ground. So that's super simple, and this light is going to be on the entire time that we're doing this. Over here with the IR detector, we have this yellow wire connecting to 5-volt power, and then the orange wire connecting to pin 2, and also connected to that is our 10 K ohm resistor, and this black wire connects that back to ground. And I know that seems a little bit counterintuitive, but that's the way that this works for me. In the example that CM Palmer gave, he would have swapped these yellow and black wires. So I played with that. It wasn't working for me, but if your implementation isn't working, perhaps try changing those things. And now we'll do a demo of how this works. All right, so we're looking here at the Jupyter notebook. We're going to open up this serial port, and the next thing we're going to do is we're going to get ready to start reading in the live RPM data. And so you can see now there's 0 RPM, so we're going to go to our sensor. As I move my finger through here, you can see the light switching. That means that I'm breaking the beam between the sensor. And so we should see on the graph now that the RPMs are going up slightly just from what I'm doing with my finger. And you can see that there. So now we're going to turn the fan on. I'll press this button here, make sure I keep the wires out of the way, and now I'm gonna put the fan in between. You can see the sensor light blinking really rapidly on the Arduino. And now if we look at the graph of our data, we can see that our RPMs are up near about 4,000 or 5,000. It varies a bit, but as you can see, we're getting pretty accurate RPM data from what's going on here. And as soon as I remove the fan and I'll turn it off, we can see that our RPMs drop back down to 0, so it's doing exactly what we were hoping for. So now that the demo is completed, we can see this graph. You can see where I was using my finger down here near about 10 seconds, just for like very small RPMs. And then in this middle section here, that's when I had the fan on and then everything was off. So the graph looks exactly as we would expect. Slight anomalies up here, and that's probably just from the data not being perfect, and we're not worried about that too much. And the final thing that we'll do is we'll just run this last cell, and that will output a RPM data CSV. And so if we refresh this here, we should see it. To go back. And now this is all of our RPM data and time, and we would be able to export that into something like Excel if we wanted to. So this went well, and the project is completed as intended, and we have a great RPM detector here, and anything, you don't need a fan, anything would work for figuring out the RPMs just by breaking that beam of light between the detector and the emitter. Thank you.